তারপর উত্তর দিল বীরবল প্রিয়তম বন্ধু আমার, ঠিক বলেছো, একটা ধাঁধা অবশ্যই আমাকে বারবার যেন আমাকে বারবার আঘাত আনাচ্ছে। ধাঁধার উত্তরটা আমি কি করে পাবো? ধাঁধাটা কি? And I tell truth which came to me in the passing is now my cause of worry. I am troubled because I cannot find an answer to a simple question. What is the fastest thing of the planet? বলছি পৃথিবীতে সবথেকে দ্রুততম প্রাণী কে? এই প্রশ্নটা আপনাকে বারবার তাকে বলছে।
Hello everyone. Today we will discuss questions on increasing and decreasing functions. Okay, so let's start with questions. The first question is, the interval in which fx is equals to 2x cube plus 9x square plus 12x minus 1 is decreasing. Okay, now whenever when we say a function is decreasing, whenever its derivative is negative. So we have to determine for which x the derivative is less than 0. So let's calculate. If we differentiate it, 6x square plus 18x plus 12 less than 0 is the 6, so x square, 3x plus 2 lesser equals to 0. Then we have to factorize it. If we factorize it, it will give me x plus 2 into x plus 1. Now if we want to solve this inequality, we have to use the wavy curve method. So what is the wavy curve method? The wave curve method. So first of all, we should find the roots of this equation. There are -2 and -1. These two are roots of this equation. So draw a number line and mention this -1, -2 and -1. Now we have to consider these subparts, all of these subparts, and find what will be the value of this inequality. So let's find out from this. Say here, what is the value? X is greater than -1. So let's think about 0. X equals to 0 lies on this range. So if we put x equals to 0 here, you will see that in the left hand side it will be 2 into 1, that is equals to 2, and that's not less than 0. So x does not belongs to this region, as in this region this inequality is not satisfied. Now if we consider this middle region, let's take a value -3/2. This -3/2 lies in between it. So if you put this -3/2 in this inequality, you will get positive value from this, as -3/2 is greater than less than +2. So it will give a positive value, -3/2 plus 2, and -3/2 plus 1, it will give you a negative value, and the inequality is satisfied in this range. Now let's consider this range where the x is less than -2. Suppose I am putting the value x as -3. X as -3. Now if you put -3 here, you will see you are getting a negative value into a negative value. So that is positive, but our inequality holds the negative value. So this region is also not our required region. Hence x belongs to this -2 to 1. This is our answer. Okay, let's move to the second question. This wavy curve method is important. Now question number 2. Let's wait for another question. Okay, our next problem is, suppose our function is y equals to x square e to the power minus x. Now we have to find the interval that this function is decreasing in which interval? Again decreasing. So our y is equals to x square e to the power minus x. So similarly we have to differentiate at first to get the derivative. So let's differentiate. So here you can see that two functions of x are in product. So you have to use the product rule of differentiation, that we have to keep one function as it is and differentiate another, plus we have to differentiate the first one and keep as it is the later one. So if we differentiate the x square, you will get 2x e to the power minus x plus x square as it is. If you differentiate e to the power minus x, it will give minus e to the power minus x. So my final derivative will be e to the power minus x. I am taking it common, 2x minus x square. If we take it more, it will be x minus 2. Now we have to determine the interval whenever it is decreasing. Okay, so y dashed less than 0. Now minus e to the power minus x minus 2 less than 0. Now if I remove this minus sign, then the less than sign will become the greater 1 sign. Greater than 0. Now we know that this exponential function is always positive. If you see the graph of exponential function, you can see that each and every time this function remains in the positive y-axis. So exponential function is always positive. So if we remove this, that doesn't left any effect on this inequality. Now we have to use the wavy curve method again. Now we have this inequality x minus 2. So what are the critical point of this inequality? As you can see, if I put x equals to 0 and x equals to 2, this inequality will become 0. So here x is 0 and here x is 2. Now suppose this region, say x is greater than 2. If x is greater than 2, then x is positive, and also x minus 2 is also positive. So this inequality holds. So this region, we will consider this region. Now for this region, suppose we are taking say 0 to 2. Here x is positive as it is, but this x minus 2 will be less than 0, as x lies between 0 to 2. So our inequality will become less than 0 as x is positive but x minus 2 is negative. So if we multiply a positive term and a negative term, it will give a negative term. So this region doesn't hold. Now consider this region. Say in this region x is less than 0, so it is negative. X minus 2 is also less than 0 as x is negative. Now if we multiply two negative values, it will give me a positive value. So this region also satisfies my inequality. So my required region required interval where my function is decreasing is nothing but minus infinity to 0 union 2 to positive infinity. This is my answer. I hope it is clear. So let's move to the next question. Question number 3. Question number 3 is asking that in which interval the function fx equals to 2x cube minus 15x square plus 36x plus 6 is increasing. Okay, so we have to differentiate it at first. We will get 6x square minus 30x plus 36. Now as it is asking about the increasing function, so we have to take the derivative as positive. Okay, so let's take out common 6. So we will get x square minus 5x plus 6 0. It will become x minus 2 x minus 3 greater equal to 0. So our critical points are 2 and 3. So let's put these values. Now if you took a value from this region greater equal to 3, greater than 3, then you will get x minus 2 is also positive in this region and x minus 3 is also positive. So their product will be also positive. So this is a correct region. This is a correct interval actually, not region, interval. So this interval, in this interval fx is increasing. So what is this interval? This interval is 3 to infinity. Now let's consider this region. If x belongs to 2, 3. In this region x minus 2 is positive but x minus 3 is negative. So if we product them, we will get a negative term and that means our inequality will not satisfy. So this interval is not our required interval. So we will discard this interval. Now the last interval. Suppose x belongs to minus infinity to 2. Okay, in this region if you see x minus 2 is negative clearly because I am taking a value less than 2 and x minus 3 is also negative. So if we product them, we will get a positive value as these two are negative. Okay, so this region, in this interval, our function is also increasing. So write the answer. our required interval is minus infinity to 2 union 3 to infinity. This is our correct answer. Let me erase it first. Let's move to the next question. Okay, so that question we have already done, the x square. Okay, just give me a 5 minute. Okay, so let's move to the next question. My next question is, prove that the function x cube minus 6x squared plus 12x plus 5 is increasing on R. It means for all values of x increasing on R. R means the real number line. So we have to show that for all values of x, the functions, the derivative of its of the function is greater than 0. So let's differentiate it. Three x square minus 12x plus 12. Now for increasing we have to take this derivative greater than 0, or no, we have to show it is increasing. Now take 3 common, we will get x square minus 4x plus 4. So it's clearly x minus 2 whole square. Now 3 is positive, of course 3 is positive, and a whole square term, a square term is always 0 or positive. It means a whole square term is non-negative. Okay, so it's clearly fx is greater or equal to 0. It does not depend on x. So whatever value I put of x, this value will always be positive. The derivative is always positive. So our function, clearly our function for all x belongs to real number, so fx is increasing on R. Okay, let's move to next question. Okay, so question number 4, fx is equals to 3x plus cos 3x, sorry, cos 3x. We have to show that this function is increasing on R. Same kind of approach. Now we have to differentiate it. F dash x is 3 minus 3 sine 3x. So let's take 3 common out, 1 minus sine 3x. Now if you have a little bit knowledge of trigonometric function, you can easily see that my sine x lies between 1 and minus 1. Okay, so if I multiply a minus, it will become minus 1 minus sine 3x 1. Now add 1 in both sides, 0, 1 minus sine 3x plus lesser equals to 2. Then multiply 3, so 0, 3 sine 3x lesser equals to 6, sorry, lesser equals to 6. So it's clearly this derivative is greater equals to 0. As you can see, I have solved this inequality here. This is nothing but the f dash x, sorry, this is f dash x. So f dash x lies between 0 and 6, so f dash x is positive whatever the value of x. So the function is increasing on the real number line, it does not depend on x. So moving to the next question. Our next question is, prove that the function fx is equals to x square minus x, where x belongs to closed 1 to open 2 is strictly increasing. Okay, so now you can see that here this box x or greatest integer function is used, and in our first video of continuity and differentiability we have already discussed what is the greatest integer function. So I am not discussing here again. So this is our fx is x square minus box x. Now if x lies between 1 and 2, our box function will return the value 1. As you can see in the graph, if I draw a graph, suppose x lies between this 1 to 2. Suppose x equals to 1 and this is 2. So that is the open interval and 2. In this range, my value here is 1 and here is 2. In this range, my function will return the leftmost integer, that is 1. So this is x square minus 1. So that's a good question for boards. So for solving this, you have to keep in mind that greatest integer function only returns the integer value. You have to be careful about it. Okay, so in this region 1 and 2, my box function will return 1. So my fx becomes x square minus 1. Now let's derivative it, differentiate it. 2x. Now x lies between my 1 to 2. So 2x is greater than 0. Of course, as x is already positive, so I am multiplying a positive term with it. So it is positive. Okay. So fx is strictly increasing. That's a very important question for your upcoming exam. This is very important. Okay, let's move to the next question, number 6. Okay, so next question is the function fx is equals to tan x minus 4x is strictly decreasing on minus pi by 3 to pi by 3. Okay, so let's differentiate it. What is my given fx? My given fx is tan x minus 4x. So differentiating it, I will get f dash x sec square x minus 4. Now x lies between minus pi by 3 and pi by 3. Now if we apply sec x, we will get 1 and 2. So square it. After squaring it, we will get sec square x sec square x and 4. Now if we minus 4, it will give a minus 3 sec square x minus 4 less than 0. So you can clearly see that my derivative is negative if x lies between pi minus 3 to pi minus 3. So that is less than 0. So f is strictly decreasing. That's also an important question here. Now let's move to another question. Question number 7. This is also from NCERT exemplar. Suppose that fx is equals to 2x cot inverse x plus log root over 1 plus x square minus x. Now we have to show that this is increasing on r. Okay, So let's differentiate it first. F dash x, it's 2. Now if we differentiate cot inverse x, we will get minus, yes, right, minus 1 by 1 plus x square. Now that's a tricky one. We have to differentiate this. So in log x, we will differentiate it and get 1 by x. So at first we will get root over 1 plus x square minus x. Then we will differentiate these values. That will give us 2x 1 plus x square minus 1. So that's my differentiating value. Here also a 2. Let's simplify it. So let's cancel these 2. So after simplifying it, I will get 2 minus 1 plus 1 by 1 plus x square and plus 1 by root over 1 plus x square minus x minus root over 1 plus x square divided by root over 1 plus x square. That will return, cancel it, 2 minus 1 by 1 plus x square minus 1 by root over 1 plus x square. Now x square is greater than 0. Since x square is greater or equals to 0 for all r, for all x belongs to r. So 1 plus x square is also greater or equals to 1, and so root over 1 plus x square 2 greater or equal to 1. It implies root over 1 by 1 plus x square will be lesser or equals to 1, and root over 1 plus x square will be lesser or equals to 1. So let's put all of these values here. We will see that my f dash x, let me write it again. What is my f dash x? 2 minus 1 by 1 plus x square minus 1 plus x square. This value is lesser equals to 1. This value is lesser equals to 1. So we can see that these two values all less than this positive value, that is 2. So my inequality will be, my derivative, sorry, not inequality, my derivative will be greater or equal to 0, because at max these two values will become 1 and then our derivative will be 0. Otherwise in every x it will give a positive value. So we can see that fx is increasing in R. Okay, so this part is so important. Sorry, I've accidentally erased it. This part is very important part of this problem. We have to remember this part. Okay, let's move to another question. Next question is, let me see the question number. That is question number 8. Okay, so question number 8 is, show that for a greater equals to 1, fx is equals to root 3 sin x minus cos x minus 2ax plus b is decreasing in R. Okay, so let's differentiate it. Three minus cos x, this is plus sin x minus 2a. So this is the derivative. Now we have to simplify this. So let's take a 2 common, then it will become root 3 by 2 cos x plus half sin x minus 2a. Then I can write this as 2 cos pi by 3 minus x minus 2a. Okay, now this we know that cos pi by 3 minus x, the whatever value of cos, it lies between minus 1 to 1. Now let's multiply with 2. 2, then subtract 2a. Now as this a lies between, this is important, the a is greater or equal to 1. So a could be 1 as minimum. So if you put 1 here, this is f dash x will be equals to 0. Okay, and if you put greater than 1, then this 2 minus 2a will be a negative value. So you have to write it here as a is greater equals to 1, 2 minus 2a is lesser equals to 0. Hence our f dash x is also lesser equals to 0. So clearly f is decreasing in R. That's also an important problem. Okay, now let's move to question number 9. Okay, so question number 9 says that suppose we have a function fx equals to log sin x. I hope you all can recognize this problem. This is from NCERT. So function is fx equals to log sin x. We have to show that this fx is strictly decreasing on 0 to pi by 2 and strictly increasing and strictly decreasing on pi by 2 comma pi. Okay, so let's solve it. Okay, so we have to differentiate it at first. So we will get fx equals to log sin x. If we differentiate it, we will get 1 by sin x at first, then we have to differentiate this sin x, we will get cos x, became cot x. Now for we will discuss in this both two intervals the cases of for both these two intervals. So first of all, if x lies between 0 to pi by 2, okay, in this range you can see cot x is always positive. We have already aware about the values of cot between 0 to pi by 2. It was taught in our class 9. Okay, so in this region clearly cot x is positive, of course. So f dash x is also positive in this region. Hence, what can I say? We can say that f is strictly increasing on 0 comma pi by 2. Okay, now let's consider the second interval. If x lies between pi by 2 and pi, so in this region if we calculate the value, you will see that cot x is negative. It's kind of obvious. In class 11 first chapter of trigonometry, you have already learned the formula that it's not a formula, it's a concept to remember: all sine tan cos. What does it mean? That in first quadrant all trigonometric functions are positive. In second quadrant sine and its reciprocal cosec is positive. In third quadrant tan and cot x is positive. In fourth quadrant cos and sec is positive. So if x lies between pi by 2 and x, okay, if x lies between pi by 2 and x, pi by 2 and pi, so what does it mean? It means that x lies in this second quadrant. So in second quadrant cot x is negative, so my f dash x is also negative. We can conclude that f is strictly decreasing f is strictly just a second. Strictly decreasing on pi by 2 comma pi. Okay, that's also an important question. Let's move to next question, question number 10. Okay, so I be an interval. In this question it is given that I is disjoint from the interval minus 1 to 1. Okay, I is disjoint to the interval minus 1 comma 1. So we have to prove that the function fx is equals to x plus 1 by x is strictly increasing on I. So we have to determine the interval I first, then we will differentiate the f and we will see it is increasing or not. So solution, first see what is the interval I. So I is disjoint from this interval. If you consider the real line, so this is the -1 to 1, so you can see disjoint. So I is nothing but this 1 to infinity and this -1, minus infinity to -1. Okay, so that's the value of I. So what is our I? Our I is nothing but minus infinity to -1 union 1 to infinity. Now differentiate it. 1 minus 1 by x square. Okay, so simplify it by x square minus 1 divided by x square. Now for x less than -1 or x greater than 1, we can see that this x square is always positive and this x square minus 1 is also positive. It's clear, as this x square is a square term, if we put any value lesser equals to less than -1 or greater than -1, we will get a positive value. It's simply clear. So my f dash x will be also positive. Okay, f dash x is also positive for all x belongs to I except x equals to -1 and 1. Okay, but if you put -1 and 1, we will get this derivative as 0. So the function is strictly increasing on I. Okay, important one. Let's move to next question. Question number 11. Okay, so next question is find the interval in which fx equals to x to the power x is strictly increasing. It is given that x is greater than 0. Okay, so fx is equals to x to the power x, a function to the power another function. We have already learned about this kind of function, that how to differentiate it in our continuity and differentiability chapter. So if this kind of function appears, we have to take logarithm in both sides. So taking logarithm both sides, it will give log of fx equals to log of x to the power x, that is x log x. Now differentiate it. With respect to x. Fx f dash x. So keep x as it is. If you differentiate log x, you will get 1 by x plus, keep log x as it is, differentiate x, we will get log x. So that is 1 plus log x. From this I got f dash x as fx into 1 plus log x x to the power x 1 plus log x. Okay, now f dash x, we have to show that that is strictly increasing. This f dash x is greater than 0 if and only if 1 plus log x greater than 0. Now x to the power x is greater than 0, as it is clearly as x is greater than 0. Okay, so we can remove this log x greater than 0. So log x greater than -1. So x will be greater than 1 by e. Okay, so what is our interval? Our required interval, that strictly increasing in 1 by e to infinity. Okay, let's move to the next question. Okay, so we have to find in which interval fx equals to 10 minus 6x minus 2x square is strictly increasing or strictly decreasing. Sorry. So we have to differentiate it at first, then we will in first case of increasing, we will take the derivative as greater than 0, then we will determine the value of x, and for the decreasing case we will take the derivative as less than 0 and will determine the value of x. This is also a problem from NCERT. Now fx after differentiating it, we will get f dash x minus 6 minus 4x minus, take the minus 2 common, which will be 2x plus 3. Okay, so let's take if f dash x is greater than 0. then minus 2, 2x plus 3 is greater than 0. If we remove minus 2, our inequality will become less than 0. So our x will be less than minus 3 by 2. So f is strictly increasing in minus infinity to 3 by 2. Okay. Now if f dash x is less than 0, we are now discussing about the decreasing case. In a similar way, we will get the answer. F is strictly decreasing in minus 3 by 2 to infinity. Okay, so that's much problem for today. I'm writing some notes for you that is important for your exam. So the proof of that note is not included in your syllabus. Just remember it. Okay. So theorem number 1 is theorem 1 states that if a function f is continuous in the closed interval ab and derivable or differentiable in open interval ab and f dash x is greater or equals to 0 for all x belongs to a comma b, then f is increasing. You all know that. Then f is increasing on open interval a comma b. Similarly, if f dash x is lesser or equals to 0 for all x belongs to open interval a comma b, then f is decreasing on a comma b. Now if f dash x greater than 0 for all x belongs to ab, then f is strictly increasing on a comma b less than 0 for all x and b, then f is strictly decreasing. If you remove the equality sign, then strictly condition arrives, strictly decreasing on a comma b. Now the most important theorem, now I will write the most important theorem. The proof of this theorem is removed from your syllabus because to prove it you have to know the Lagrange mean value theorem, but that theorem is also removed from your syllabus. Okay, so let's write as theorem number 2. Theorem number 2 states that if function fx is continuous on closed interval AB and differentiable on open interval AB f dash x greater than 0 for all x belongs to open interval a comma b except finite number of points where f dash x is equals to 0. Then fx is strictly increasing in in closed interval AB. Similarly, if f dash x is less than 0 for all x belongs to open interval AB, repeat this statement, except finite number of points where f dash x is equals to 0, then fx is strictly decreasing in the closed interval AB. Okay, that is closed interval AB and closed interval AB. This theorem is so important. This theorem you all know, but this theorem is so important. I used it in the last question also, so we have to be careful about this. Okay, so that's much today.